Alrighty, in this video we're going to start talking about direct variations, which is just another form of a linear equation. We've been dealing with linear equations for a while. Literally, an equation, when we graph it, is a line. So a direct, I don't know why this pen likes to argue so much. Let me see, I'm going to bring up the size a little bit, see if that helps. And we'll change the color just so you can kind of see. Direct, there we go. Variation. So a direct variation needs to have a constant rate of change. So that's kind of the first requirement for a direct variation. And that's kind of true of any linear equation. It's going to have a slope of a change that's going to be constant. If it goes up by 2 and over by 1, it's going to go up by 2 over by 1, up by 2 over by 1. It's going to be constant. You're not going to go up by 2 over by 1, up by 3 over by 1, up by 1 over by 1. Like, that wouldn't be a constant rate of change, right? I couldn't draw a nice straight line between the points here that are made. So that's pretty common when we have a linear equation. A direct variation also needs to pass through the origin, or point 0, 0. So that's another big requirement for a direct variation. We're not going to be off center at all when we're talking about the coordinate grid here. We're going to go right through the center, and it's going to go kind of right straight through there. It can also go down. It can be negative, but it needs to go through that center point. To write an equation using y varies directly with x, that's always how we read a direct variation. It'll say y varies directly with x, and it'll give us a little bit more information, but those are the words they use. I like to change it with this varies directly with that, because when we're talking about word problems, which is kind of what I put in the parentheses here, we're not going to have y and x. We're going to have something, this, and it's going to vary directly with something else, that. So I kind of like to change it to this and that, especially for word problems, just so that you're not always going to be looking for x and y. Sometimes it's something else. On this screen, I think we're just going to deal with x and y, so not too big a deal. But the formula is going to be y equals kx, and this literally says y varies directly, so y varies directly with x. Okay, so equals k means varies directly with. That's kind of how we read that, okay? So this is the idea of that equation. Y varies directly with x, y equals kx. So I'll leave that there, I guess. That's all right. It's a little sloppy, but so for each table below, we're going to determine if it shows a direct variation. If it does, write its direct variation equation. So first, we need to make sure that it has that constant rate of change. That was our first requirement, just to see if it's even linear. Okay. So all we have to do is go y over x, rise over run, 1 over 2. And then the next one, we're going to go 2 over 4 for this next one. We're going to reduce it. 2 over 4 is 1 over 2. And then the next one, we have 3.5 over 7. So 3.5 and 7, this might not be as recognizable, but 3.5 times 2 is 7. So it's going to be 1 over 2. And what I'm doing here is reducing. Sorry, I just kind of started doing that without explaining. But I'm dividing by 2, I'm dividing by 2. So 2 divided by 2 is 1, 4 divided by 2 is 2. And then with this one, I'm actually dividing by 3.5 and 3.5. Because 3.5 times 2 is 7. So 7 divided by 3.5 is 2, 3.5 divided by 3.5 is 1. So yay! We have the exact same ratio on all of them. So we have our first requirement here. That is going to be our actual varying piece. So it's going to be the 1/2. The other thing we want to make sure is that it does in fact pass through the origin. So if we look at the pattern here, we're going, this one I went by 3, right? So that changed by 3, this changed by 2. And over here, this changed by 1. And this changed by 1.5. So it's a little different, but for this one, this is actually, I kind of explained that a little funny. So this is the ratio for the direct variation. this is the constant rate of change when we look at x to y. So if I look at this one, I have 1 over 2, like that. So 1 over 2 for this first one. And if I look for the second one, I have 1.5 over 3. So they're not the same, but they actually are the same because we can reduce. 1.5 is 2 times 2, is 3. So I can divide by 1.5 on both top and bottom, and I get 1.5 divided by 1.5 is 1. 3 divided by 1.5 is 2. So they do have a constant rate of change of that 1/2. So that still gets us the 1/2, but this is a little bit better description of the constant rate of change when we are comparing the actual change in the y's over the change in the x. So because I know for every 1 I'm changing for y, I'm changing 2 for x. If I want to get to 0 and I want to go backwards, if I'm adding 2 to go this way, I can subtract 2 to go this way, and I would end up with 0, because 2 minus 2 is 0. And with this one, I added 1 to go this direction down, so to go back up, I'm going to subtract 1, and I'd end at 0. So that does, in fact, start on 0, 0. So this is a direct variation. We just checked off kind of those two boxes. Yes, it has this common ratio for the change in x and the change in y, and then it also goes through 0, 0, which is one of the bigger requirements of direct variation. So now we're going to say y varies directly with x. It's the 1/2 x. So whatever x is, it's half of that to go to y. So 2 divided by 2, half of 2 is 1. Half of 4 is 2. Half of 7 is 3.5. So that's that idea there. All right, let's look at this next one. So we're going to do that same thing. We're going to look at the ratios. So we're going to have 2 over 5. And then 6 over 15. I can't reduce 2 and 5, so I'm going to leave it 2 and 5. For 6 and 15, they can both divide by 3. So 6 divided by 3 is 2. 15 divided by 3 is 5. Oh, so we have 2/5, 2/5. So I need to check that last one. 35 over 25. So these can both divide by 5 for sure, because they both end in 5. So I'd have 7 over 5. So this one does not work. I have 5 on the bottom, but that is not the same ratio. So this is not a direct variation. So I can stop. I don't need to check any further. So I only need to go to that, checking that 0, 0 part and making sure that it does in fact work if this is not a correct ratio. All right. This very last one, we have another direct variation, but they're giving it to us kind of a little bit more, not word problem, but a little bit more with words. So suppose that y varies directly with x, and y is 2 and x is 16. So remember, y varies directly with x. So we have y varies directly with x. That's that equation that we're just talking about up here. So we're going to find k. We're going to find this k here. And k is the constant of variation. So it's that, spelling variation funny. Okay. T-I-O-N. There we go. I don't know why I was putting too many R's and A's in there. So this is the constant of variation. That's that ratio we were just checking above. We need that constant of variation to write our equation, because if you remember, that is the equation. We're not actually going to have x and y with numbers in there. We're going to literally leave them x and y. The only number that gets filled in is that k, that constant rate of variation. So using y equals kx, we're going to create an equation using k once we find it. And I'll explain how we're going to find it in just a second. And then we're going to plug in the given number to find y in the second part, because we're given two parts. Okay, so to find k, I know what y and x are, so we're going to plug these in really quick. Y is 2. I don't know k, that's what I want to find, but I do know x is 16. So now all I have to do is divide that 16 away from both sides, because I want to get k by itself. 16 divided by 16 cancels. And then this one I just need to reduce. So I don't want to say 16 divided by 2. Be careful about that. This is 2 divided by 16. So I can reduce. 2 divided by 2 is 1. 16 divided by 2 is 8. So be very careful about how you divide, because I see students do this kind of upside down all the time where they look at this and go, oh, it's 8. It's 1 over 8 because I'm doing 2 divided by 16. So I have my constant of variation. So now I can just, boop, plug this guy back into that equation up top there. So I'm going to have y equals 1/8 x. So that's my equation. Now I'm going to use this equation to answer part B. So we're going to find y when x is 7. So now I know my equation is y equals 1/8 x. Well, I know what x is. They just told me x is 7. And they want me to figure out what is y. So I'm just going to simply multiply. And remember, you multiply across the top when we're doing fractions. So 1 times 7 is 7. And we divide by the bottom, which is 8. And I can't reduce that anymore. They're not asking me to do any kind of fraction, or I'm sorry, not asking me to do any kind of decimal or rounding. So I'm going to leave it 7/8. And that's my answer. And with this one, the last piece here, it's saying, is there a pattern? Well, if we're talking about a direct variation, yes, there needs to be a pattern. So with this one, the pattern would be y is going to be 1/8 of x. So, I don't have to put so. Y is x. We can say 1/8 of x or x divided by 8. That's the pattern. Every x I have, if I divide it by 8, I'll know what my y is. So that's the pattern that I'm looking for there. All right, so that was the kind of beginnings of our direct variations. And go ahead, Alex, and give that a try.